right, I'm just getting a few things set up here. This stream is sponsored by Microsoft Azure. We'll be using Azure to hopefully accelerate the training of our reinforcement learning agent. So if you remember what we did last time, we got VizDoom working. There was a reinforcement learning agent that was trying to be the Doom Slayer and shoot an enemy, and it didn't go so well. We noticed that there wasn't really any mechanism for kind of retaining the experience that the agent was having. Like, that was on purpose. And so we weren't actually learning. It was just picking a random action each time. And when the reinforcement learning agent like just stumbled across a good action, aka shooting the enemy, it was more luck than it was actual learning. So we're gonna need a couple different things. We're gonna need a learning rate. We're gonna need a discount. We're gonna need a memory buffer. We're gonna need the number of training epics, the steps per epic, the number of steps and update steps, batch size, the number of test episodes per epic. Oh, we need a frame rate. And we need to load something. We're not gonna skip learning because we obviously want that. And then whether we're gonna save the model. We're gonna use the same config we used last time. How many training epics do we want to do? Let's do one to start, just so we can make sure things work. And the number to update. Batch size. Number of, we'll do 100. Oh, I probably need a resolution, don't I? Did I not say? Oh no, this is a different resolution. And then, no, I don't want you to load a model. I want you to do a new one. All right. So here's how this is going to kind of work. We're going to need to, like, when our agent is interacting with the environment via a game, it's kind of like processing video data or processing image data, right? Because video is just a series of images. We're going to need to pre-process the images, essentially like the video, if you will, of what the agent is seeing. Or, you know, in this case, it would be what the player would see. And as we're playing a video game, a lot of times it's like an interactive video. So you have the environment state is something that we can use computer vision to just read in. So that's where we're going to start. Obviously, we're going to need VizDoom. And for that, let's make a function here that's just going to start the game for us. We're going to do a lot of the same stuff that we did last time, right? We need to instantiate a Doom game. We're going to, unlike what I forgot last time that caused some problems, we are going to load in our configuration file. We are going to set the mode as player, because we are the player. And then there's some resolution and screen format settings that I noticed being used quite a bit. I didn't have time to play with a bunch of other ones, so this is just what worked for me. But feel free to obviously set things at whatever you would like. And then we need to init our game. All right. Cool. So now this will let us initialize a game, load in our config. We've set the mode, we've set the screen stuff. We can see it. Yes. This is essentially the stuff that if you look back at the simple scenario we did yesterday, it's basically a lot of this stuff, right? I'm just wrapping it in a function because this is going to be a lot more code than the simple example we did on Tuesday. So I just want to encapsulate stuff a little more cleanly. We also need to pre-process. So we're going to use scikit image, that library, just to pre-process the kind of screen capture that we're going to have. We're going to resize it. That's fine. Then, yeah, we need to cast this. Oh yeah, gotta reshape. Okay, cool. So now we can pre-process the data, we can resize it, we can make sure it's the right data type, the right shape for our neural net architecture. We are good to go. Let's call this, agent. Super secret agent. And we're gonna need a couple of different things. So we're gonna have the number of actions. Now, I know last time when we were doing like this super simple example, we only had, if you remember, we only had 3 actions: move left, move right, and shoot. But now I would like to be able to have, let's see, I want you to be able to have combinations of actions. So then we are going to have other things that are in Q-learning. So we need an epsilon. Start with 1. And we're going to decay our epsilon by, that works. Let's just put all these in a line so it's a little easier to read. And then whether or not we load a previously trained model. Cool beans. So epsilon here is talking about the balance between exploration and exploitation. And so this is something we talked about on Tuesday, right? But exploration being you choose a random action, exploitation being you're trying to choose the best action. And so if we have a epsilon of 1, what that means is that means that with 100% probability, you're going to be choosing a random action. So we're starting out 100% exploration, which makes sense. We don't know any, like, when you first start out, your like very first state agent training episode, right? You don't know anything. You have no history. Unless you're obviously loading a pre-trained model or something, but you don't know anything. Your agent doesn't have any memory, right? Doesn't have any experiences to pull from. So you can't have an epsilon of anything other than 1, because if you try to ask the reinforcement learning agent to choose the most valuable action, it's going to not know what that is, because we haven't even tested out any actions and seen their value. We're going to start with 1, so we're going to be 100% exploration, decreasing over time to favor exploitation more and more. So the more you learn, we don't want to, after 1 pass through this scenario, always choose the best action, because our state space is quite complex. And so we want to still have that exploration, that choose a random action, which allows you to find better and better strategies. Okay. And I'm going to need some of our settings for that. So what else do we need to do? TensorFlow. Oh my god. Save. So we're going to need be good. All right, I'm gonna remember that in the future, we're gonna call our class, we're gonna have DQN. All right, so then we're gonna need to give it the number of actions. Now we've got our agent, we have our parameters, we've set things, we've decided if we want to load the model or not. Some stuff from TensorFlow. All right. Import a model. It's not capitalized, right? Yeah, it is capitalized. Okay. Which ones did I use? All right. What are we gonna need here? So earlier I was talking about architecture, right? We kind of need to set a lot of that architecture right now. So we're gonna set the blueprint. We're gonna make the blueprint for our deep queue network. And I'm going to trust the things that I used previously. So where are my notes? Right, and input shape is gonna be, oh no, but I need it to be another dimension. Yes, all right, and then normalize, and then ReLU. We're gonna use very similar for block numero dos, except we're gonna have small kernel size, 14 and 8. Yep, cool. And then we're gonna, so give it that. We're gonna pass it through the different layers. And then, oh yeah, splitting it. Cool. All right. Okay, so we need a way to update the target. Right. Okay, what else do I need? I need to, we need to figure out a way to choose an action. That's pretty important, right? So given a state, right, our reinforcement learning agent examines a state and chooses an action. If we want to exploit, or whatever our epsilon is set at is less than a random number between 0 and 1, which will happen with the exact same probability of as what we have set our epsilon at, then we want to have the best action. So if we are exploiting, we need to have state. So we need to now have our exploration. And so it's going to be random. All right, so this is just your exploration-exploitation trade-off. When we have epsilon of 1 to start out with, the first condition will never be met. So epsilon's never going to be less than 1. And it's never going to be less than any number randomly chosen between 0 and 1 because it's going to be 1. So that means at the very start of our training, the first conditional there is never going to be met because we are 100% focused on exploration. We've chosen an action. We need to train. So we need to train. And what are we going to do for this? We're going to need rewards. The next screen. Right. And we need to be able to get the screen is. So essentially, we're going to get a lot of information all kind of stacked together in a giant, like a giant array or a giant tuple. And so what we need to do is we need to split that out and return it in the order that we want to actually have these things be used. Actions, rewards. And then this is 4. 0, 1, 2, 3, 4. Yep, okay. The screen, the actions, the rewards, the next screen, and the things we've done. All right, cool. There we go. This is going to be our rewards plus our discount times predicted next Q value. All right, and then do error. Now, okie doke. So we're going to decay if we haven't reached the minimum. Otherwise, we will stay the same. I'm going to need another helper function to pull samples of experience out of our agent's memory. And so, sample size, batch size, bath size. Starting a new epic, and we're gonna have our training scores. So then, new episode of our game. We need to get our state. We need to get our action. Then we need to okay, train scores. We need to add in the total reward that we have. Ah, yes, and start a new episode. Right, that makes sense. And done. And then so what else do we need to do? And right. So I need to write the test real quick. Write the test. And this is going to be similar. Same thing as before. Cool. So now in our run code, we can test. I liked this. There we go. All right. Cool. So testing. We start our game. We need our memory. State, screen buffer, which is an action based on our state. Okay, all right, so I got this up. And so obviously you can see, like, unlike before where I had it going much slower, we're gonna want this to be like zipping through. You can tell the episodes where it has selected a non-random action. You can tell because it just like jumps right to shooting the bad guy. So we're getting better. And then you can definitely tell the episodes like this one where it's choosing a random action. I like watching it though. I think this is one of the fun things to me, at least, about machine learning, is it's really fun to watch something learn. But yeah, so ideally what I would like to do is, if you look at the reinforcement learning documentation on Azure, we've gotten a lot of this set up on a previous stream. But what we would just need to do is make this estimator to submit the training job, you know, define the parameters and stuff, define our estimator, write an entry script, so a training script. So we might have to like chop up the thing that we just had, make it kind of in the Azure format. But I really want to I like the visualizations that you have in like the Azure reinforcement learning. So I would love to see if I could get this working. Unfortunately, like I said, it's incompatible with the version of Python that I got the Vizdoom stuff working with. I'll have to come back to it and figure out how to get both of them to play nice with each other. But I will see you all hopefully very soon.